When you stand on a beach and look out at the water, it is easy to picture the ocean as a giant, still bathtub, a single, massive pool of blue water stretching all the way to the horizon. But descend through the sunlight and dive thousands of feet into the freezing dark, and that uniformity disappears. Down here, tracing the contours of the rock, you will find entirely distinct, fast-flowing rivers of liquid carving their way across the ocean floor without ever mixing into the water floating right above them. It sounds like a glitch in physics. If the ocean basin is already completely full of water, how can an entirely separate river flow inside of it without instantly blending together? The tranquil surface we see every day masks a set of fluid dynamics that defy common sense. To understand these hidden flows, we have to rethink exactly how water behaves. These flows are driven by two specific variables: temperature and salinity, or how much salt is dissolved in the water. When these variables change, a pocket of ocean with a sharp drop in temperature or spike in salt content dramatically increases in density. This heavier water plummets through the lighter water, hitting the floor and pooling into a horizontal current. That extreme density difference acts like an invisible physical wall. The heavy liquid resists blending with the lighter water above it, allowing it to maintain its structure and flow independently. The ocean is completely stratified. It is a stack of different liquids sliding past one another, and this physical separation of densities is the exact mechanical engine driving these underwater rivers. Scaling those fluid dynamics up to planetary geography, the results are staggering. The ocean floor is heavily scarred with deep trenches and sheer vertical drop-offs. When a fast-moving, dense river reaches the edge of one of these abyssal cliffs, it pours over the edge in a massive underwater cataract. Millions of cubic meters of heavy fluid cascade downward every second, generating tremendous kinetic force as it crashes into the deep basins below. These are entirely unlike the gentle streams we see on land. These are colossal, roaring waterfalls, operating submerged in the freezing, pitch-black crush of the deep sea. These extreme features prove the seafloor possesses a highly active, dramatic geography of its own, sculpted and driven completely by the laws of density. These deep-sea rivers and massive drops all connect to form an unbroken planetary-scale network. Looking at this global map visualization, you can trace the continuous paths of these deep ocean density currents. They loop around continents and connect the world's oceans in a giant submerged conveyor belt. 24 hours a day, entirely out of human sight, this system sweeps massive amounts of salt, vital chemical nutrients, and trapped heat across vast distances. These heavy, hidden flows operate as a critical, invisible engine, actively regulating the Earth's global temperatures and sustaining marine ecosystems worldwide. When you view Earth from space, the vast expanses of blue ocean appear incredibly peaceful and still, but knowing what flows beneath that surface reveals a planet in constant, heavy motion. The oceans hide violent geological extremes, from active volcanic structures venting massive plumes into the air to endless trenches and colossal, fast-moving rivers of dense water in the abyss. Nature operates its most massive and dynamic systems out of sight, beneath the waves, where the weight and temperature of the water itself dictates the movement of the world.